Use Gaussian elimination to solve the system 2x plus 3y minus z equals 1, x plus 2y equals 3, and x plus 3y plus z equals 4. I'm going to rewrite this system over here just so we have a little bit more room to work with it. So we've got 2x plus 3y minus z equals 1, x plus 2y equals 3, and x plus 3y plus z equals 4. And remember, what we want to do is we want to take these three terms and eliminate them so that we can use substitution to go back and solve for the variables. So what we're going to do is we're going to leave the first row alone because we don't need to eliminate anything in the first row. And then we need to use row operations to get rid of these two terms, both of which are x. So what we can do to get rid of this x is we can actually double this equation, giving us 2x, and then subtract the first equation. So we can take 2 times equation 2 minus equation 1. And actually, to get rid of this x down here, we could double it as well and then subtract the 2x from the first equation. So the row operation here is 2 times equation 3 minus equation 1. And these row operations are going to get rid of the x terms in the second and third equation. So let's go through and do that. For the x's, we've got 2 times x is 2x minus 2x is 0. That's going to be empty. 2 times 2y is 4y, and 4y minus 3y is just y. And then 2 times nothing is 0, and then 0 minus negative z is the same as 0 plus z, which gives us a positive z. And then we've got 2 times 3, which is 6, minus 1 equals 5. So that's going to be our second row. And then now for the third row, we're going to double the third equation and then subtract the first. So 2 times x is 2x, and 2x minus 2x is nothing. It's going to be blank. 2 times 3y is 6y, and 6y minus 3y gives us 3y. And then 2 times z is 2z, and 2z minus negative z is the same as 2z plus z, which is 3z. And then lastly, 2 times 4 is 8, and 8 minus 1 is 7. All right, so now we've gotten rid of 2 of the 3 terms that we want to get rid of. The third one we're going to need to get rid of is the y term in that last equation. And so if we want to get rid of this, we can take the third equation minus 3 times the second equation. So we're actually going to leave the first 2 rows alone. So I'm going to leave this as 2x plus 3y minus z equals 1, y plus z equals 5. And then for the third row, remember we said equation 3 minus 3 times equation 2. If we do that, we've got nothing with the x's. With the y's, we've got 3y minus 3 times y. It's 3y minus 3y, which is 0. So we've got nothing there. With the z's, we've got 3z minus 3 times z. That's going to be 3z minus 3z, which is also equal to 0. And so on the left, because everything vanishes, we're left with just 0. And then on the right, we've got 7 minus 3 times 5. 3 times 5 is 15, and 7 minus 15 is negative 8. And we are in a situation that's different from the examples in the last lesson, because here we have an equation that doesn't have any variables at all. If we look at this equation, 0 equals negative 8, we know that this is a false equation. It is not true that 0 equals negative 8. This will never be true no matter what day of the week it is, no matter where we are, if we're in San Francisco or Istanbul, 0 is never equal to -8, and it doesn't even matter what the values of x, y, and z are. This equation is never going to be true, and what that means is that our whole system of equations, we can pick any values we want for x, y, and z. It's never going to work, and thus we conclude that there is no solution. Whenever we are trying to solve a system of equations using row operations, and we end up with an equation where the variables vanish, and it's a false equation, that tells us that there is no solution, which is our final answer. Just a quick note, if you were to do this problem on your own, not with me, you might have chosen slightly different row operations, which are still valid, but in the end, you might have ended up with something other than 0 equals -8. You could have ended up with 0 equals -2, or you could have ended up with 0 equals 5 or 8. It doesn't really matter what this final equation is. You might have gotten a different one, but so long as you also got a false equation and you conclude that there's no solution, that is correct. I just wanted to say that because it's possible for students to get different false equations depending on the row operations they use, and we still come to the same conclusion at the end: no solution.